Good day everyone, welcome to another episode of my YouTube lesson. In today's video, we are going to be looking at the question under the electrolysis. In today's, we have the preferential discharge of the ion. How are we now going to indicate this kind of problems? So I have three questions here. So let's start. So here we have, what are the products of the electrolysis of concentrated calcium chloride solution? So we are given option A to be calcium and chlorine, option B calcium and oxygen, hydrogen and chlorine, hydrogen gas and chlorine, calcium, hydrogen gas and chlorine. So what you need to take note is that this kind of preferential discharge, it has three factors that we need to take note. So the first one is the position of the ion in the electrochemical series. The second one is the concentration of the ion, and the last one is the nature of the electrode. But the two most important is this and this one. And also we also need to take note of the cations and the anion that we have here. These are the cations that we have here: potassium, sodium, calcium, magnesium, aluminium, silicon, down to Ag and the Au. That is the good. We also have the anion: fluorine, SO4, NO3, ClBr, iodine, and the OH. So now let's go back to the question. So before that, let's explain the position of the ion in the chemical series. So what position of the ion in the chemical series is talking about is that if you are given any particular question and based on this preferential discharge, so let's say that provided that all other factors are constant, you get it? Provided that all other factors are constant, if other factors, like I said, if they are constant, a cations or anions, the cation or the anion that I have here that are lower in electrochemical series will show a greater tendency to discharge than those one in the up series. That is, those ones that are lower in electrochemical series, we have the greater tendency to migrate to either cathode or the anode. The cation, which is the positive, they will migrate to the cathode, while the anions, which is the negative, they will migrate to the anode. Anode is positive while the cathode is negative. So those ones that are lower in series like this, those ones that are lower in series, they will have the greater tendency to migrate rather than those that are up in the series. That's what the position of the ion is talking about. So when it comes to the concentration of the ion, so let's say that provided that all other factors are constant also, this factor is only effective only if the concentration of the two competing ions are closely positioned, if they are positioned together in the electrochemical series, if they are very close together. But if they are not close together, the cohesion of the ion will not be effective. So those ones that are below will still migrate. But if the two participating ions that are participating in the reaction, if the two of them are very close together in the series, the one that is above will now migrate if they are very close when it comes to the effect of concentration. So now let's now start. So we have the concentration of calcium chloride. So the calcium will dissociate into calcium and the chlorine. That's why it is like this. And in any kind of reaction like this, you need to mix it with water. So H2O. So H2O2 will dissociate into hydrogen and the OH, hydrogen gas, chlorine gas. So now, so we are going to have the cations and the anion of them. So we have the cations. Cations are the one that will migrate to the cathode. So we are going to have calcium and the hydrogen plus, and this one plus, and the anions, that is hydrogen, this hydrogen and the calcium, both of them are cations that we have in this kind of solution. So anions, we are going to have the chlorine gas and the OH minus. So now when it comes to the effect of the concentration, now these two will migrate to the cathode, and also these two will migrate to the anode. But which one is now going to discharge? From the question, we have the concentrated calcium chloride. So the effect of concentrated can only be effective. This concentration can only be effective only if the two participating anion, the cations, if they are very close together. So now you can see we have the calcium here. Look at the hydrogen. Hydrogen is far from the calcium. So you get it now? It's very far from the calcium. So hydrogen we have the tendency to be deposited at the cathode. So at this point now, hydrogen will migrate here for this one. So come to this one now. The OH and the chlorine are very close together. So since they are very close, chlorine gas will migrate to the cathode. Sorry, to the anode. Sorry. So let's go back to the option. So option C is right. So for the second part, we also have another question here. They said that during the electrolysis of the concentrated sodium chloride, what is discharged? What is discharged at the cathode? So sodium, write it also like this. Sodium chloride, we are mixing it with water, H2O, sodium plus, and the Cl minus, hydrogen gas, hydrogen and the OH minus. We are going to write the cations. The cations are the sodium and the hydrogen plus. The anions are the chlorine and the OH. So remember that the cation will migrate to the cathode while the anion will migrate to the anode. So this is also concentration, the effect of concentration. So which one are going to migrate between sodium and the hydrogen now? Now both of them, they are very far away from each other. Had it been they are close together like this, sodium will migrate. So you get it now? So since they are close together, so hydrogen, since they are far away from each other, so hydrogen will migrate. So hydrogen is correct there. So the last question that I have here, they said that the product formed at the cathode during the electrolysis of sodium chloride solution with platinum or graphite electrode is what? So the product formed during the electrolysis of sodium chloride. So they didn't even mention of anything like concentration here. So we are going to write the same way we are doing it. We are going to have sodium chloride and H2O. Sodium chloride will dissociate. Let me write it this one in form of an equation so that you're able to still understand it more better. So sodium chloride will dissociate into sodium plus Cl plus and minus, and the water H2O will dissociate into hydrogen plus and the OH minus. So this is the anode now. This is the cation part. Let's write it as the cations part, and these are the anions. So either of these two will migrate now. Either of these two will also migrate. This part, these are the cations, they migrate to they are positive, they migrate to the cathode. These are the negative, they migrate to the anode. So sodium and the hydrogen now. So they said the product formed at the cathode during electrolysis of sodium chloride solution with platinum graphite. They said which of these we form at the cathode. So from the question here, from our workings here, we have the cation, which is the positive. So now from the position of the ion in the electrochemical series, they said that the one that is below, we have the great tendency to migrate. So now hydrogen will also migrate here also. So come to the end of my lesson. So if you are new to my YouTube channel, please kindly subscribe to my YouTube channel in order for you to know when I post my next video. Thank you.